In exercise 506, we now move on to the concept of area. So, area can be measured in millimetres squared, centimetres squared, metres squared, hectares, etc. And by the way, a hectare is 100 metres by 100 metres, which gives you 10,000 square metres to a hectare. Now, these are conversions that you need to know, that 1 hectare is the same as 10,000 square metres. This exercise focuses heavily on converting area as well as calculating area and a few different shapes. So there's really basically 3 things we do. We convert area, the units of area. We calculate the areas of a shape, or we find the areas of shapes put together. And an annulus is a shape formed by 2 shapes being put together. Let's have a look at converting area measurements. Now, we know that, for example, we know the connection between a centimetre and millimetres is the number 10. So 1 centimetre is 10 millimetres, we know that. But when we come to square measure, we have that. We have to square everything there. So we square 1, we square the centimetres, we square the 10, and we square the millimetres. And 1 squared is 1, and that's where this comes from. That 1 centimetre squared is 10 squared, which is 100 millimetres squared. Don't fall for the mistake of saying that, oh, you know that the connection between centimetres and millimetres is 10, so the connection between centimetres squared and millimetres squared should be 10. No, it's not. Think, now we're in square measure, we must square all the numbers. It's the same with converting a metre squared to centimetres squared. Now we all know that 1 metre is 100 centimetres. And so to find the number that connects square metres to square centimetres, we've got to square everything. 1 squared is 1, and that's where this now comes from. Metres squared and 100 squared is 100 times 100. That would be 4, or 1 with 4 zeros, or 10,000 centimetres squared. You can see from above where the hectare comes from. 1 hectare is 100 metres by 100 metres. Multiplying 100 by 100 we just saw was a 1 with 4 noughts, or in this case, again, 10,000 square metres. As we work through this exercise, you'll come across different formulas for calculating area. There are only a few on the reference sheet, and I started last exercise to point out the formulas that are there. The really important thing is for you to have a look at pages 203 and 204, which lists the full set of formulas required, and any that are not on the formula sheet, and there aren't that many on the formula sheet, you need to make sure appear down in the summary at the end of this exercise. Now, one thing that I really need you to do is to fix this equation. I've copied the wrong one from the formula sheet. This symbol means that the formula's on the formula sheet. So I've copied the wrong one. The area of a sector, the theta on 360 is right, but it is pi r squared. R squared. So I think it's the second formula on the reference sheet. Could I please get you to correct your notes about that? Now, like I said, the other aspect of this exercise is going to be looking at areas created when you combine two shapes. Now, a common one is called an annulus, and it is this shaded part. An annulus is like a donut shape. So it's a big circle with a little circle taken out of the middle. And to get the area of the annulus, then we take the area of the big circle and we subtract the area of the small circle. So in this case, the area of the big circle would be pi times 7 squared, and we subtract the area of the small circle, which is pi times 3 squared. Remember, area of a circle? Now, we highlighted that on the back on page 2 of the notes. The area of a circle is pi times r squared. I'll stop the video there and do the examples on another video.